Hello, thank you for joining me. Today we're going to be talking about simulating time crystals, which is what we do in lab with my lovely advisors listed on this first slide right here. Alright, as a quick introduction, when you first think about time crystals, you might think of something like looking up in a cave and seeing a beautiful purple crystal structure, or some more abstract version of time, like in a Marvel movie, but that's not what they are at all. But that does bring in curious people, which is what science is all about. And so simulating time crystals is a pathway to not only show people what they are, but explain how they work and what their general applications are. Right, so time crystals started as a idea in 2012 that ideally a state of matter should exist in which patterns repeat at regular intervals of time, which would break translational symmetry in time. The photo to your right is actually a testable and physical data of the oscillations of time crystals at room temperature. So in a short amount of time of only 11 years, now that it's 2023, we have actual physical data of time crystals. So simulating time crystals is what we do in lab with many different programs, some of which being IBM Quantum Cloud Simulator, Python, Qiskit, and Jupyter. They produce these graphs, which you see here. The one on the left shows the oscillations of all the qubits, and you see some noise, and that's what we're researching to eliminate partly. And then the one on the right shows data from one qubit and its oscillations, as you see, going from 1 to -1. So what are the applications of time crystals? So time crystals have to do with data storage, processing capabilities, and quantum computers. Processing software can interact with quantum computers and we send them data, they send us results, or we can just simulate what would happen, such as the case with qubits and time crystals. Quantum computers outperform classical computers at certain tasks, such as semi-prime factorization, and quantum computers built from superconducting circuit elements must be operated at cryogenic temperatures, so really, really low temperatures. And as a bit of a fun fact, quantum chips from IBM are named after birds, so that means one day for a UMass Lowell, we could have a Riverhawk quantum chip. So as a short summary, ever since time crystals have been theorized and eventually realized, a lot of research has been put into them and it's been rapidly evolving. And as this topic begins to be researched more, the possibilities are seemingly endless and the excitement is never ending.